Is Llama 2 the best open large language model for commercial use? In this video, we're going to try to find out. Hey everyone, my name is Venrin, and in this video, we're going to have a look at Llama 2. It is a model that is introduced by Meta AI, which has a lot more training data, it has a 2 times larger context width, and it contains a lot of different versions of it. In this video, we're going to have a look at the way that the model was trained and a general overview of the performance of the model. Then we're going to take it within a Google Colab notebook, load it on a single GPU, T4 in our case, and we'll try to run through a couple of prompts and see what results we're getting. Let's get started. If you want to get access to the notebook that I'm going to use throughout this video, please go to the Get Things Done with Prompt Engineering and LangChain repository. I'm going to link it down into the description of this video. And here you can find the Llama 2 notebook, which contains the complete tutorial. Also, if you want to stay up to date with the latest of AI developments, and I'm going to write a bit more expanded version of this Llama overview in text within the State of AI newsletter, which I am going to send you at the end of this week if you subscribe here for free. So please consider subscribing to the newsletter. The Llama version 2 is introduced into this Meta AI blog post, and it says that they're introducing Llama 2, the next generation of their open source large language model. And as you can see, Llama 2 is available for both research and commercial uses. So if you want to download or get access to this model, you need to press here. This will go and show you this form right here where you can request access to this model or the family of models, as you see in a bit. So what is different with Llama Llama 2 compared to the first version? So one of the first things that the authors are describing here is that we have 40% more data. And another important thing is that we now have 4096 tokens as a context length. So this is double compared to Llama version 1. And this time we have 3 different models with 3 different number of parameters, 7 billion, 13 billion, and then 70 billion. So we are looking at large models with huge pre-training data. And as you can see, they're using 2 trillion tokens. And everything is wrapped within those 3 different types of models. Also, the Llama models are introduced into a causal or model for text generation and models that are fine-tuned for chat with human annotations. So there are some benchmarks that the authors are describing, and here you can see that they're comparing Llama 2, the different sizes of the models, with Falcon and MPTB. At least in my opinion, Falcon was one of the better, or if not the best, open source model thus far. We'll see whether or not Llama 2 is going to beat that. At least according to those benchmarks, it seems that Llama 2 is much better model. But yeah, it needs to pass some time and some of the people are going to evaluate it. And we have a few of whether or not this model is actually better compared to the Falcon models. And here they're also specifying that they have this chat model and other partners, etc. So one of the important things about this blog post is that they're talking about building a responsibility. So they're integrating with some of the ways to reduce the toxicity, if you will, of those types of models. And you can go through the paper that is around 76 pages long, and they describe different ways to combat toxicity and ethical considerations, etc., safety in pre-training, etc. So the paper, I haven't gone through that, but it is roughly compartmentalized into pre-training, fine-tuning, safety, and then a discussion. So they're talking about the training data, they're talking about fine-tuning in a supervised fashion, and again, they're using some reinforcement learning, and other ways to fine-tune this model. They talk also about safety. I'm going to go through a bit more detail about on this paper in the weekly newsletter that is going to be available on ML Expert. So if you want to look into my thoughts and my observations on this paper, please consider subscribing to the free newsletter. Okay, so one important thing is that the source code for Llama is available on GitHub. And here you can see that they're already implementing all of this within Llama 2. And they are referencing this Llama recipes repository where you can find different chunks of code for text generation and chat generation, etc. One of the important things is that these models are actually integrated with the Hugging Face, so we can access them. And this is the page where you can look through the Meet Llama 2.0. So this is on the Hugging Face page. And here you have a nice overview of the different models. For each parameter size, you have a Hugging Face conversion, and then you have chat and chat Hugging Face conversion. So in this video, we're going to have a look at this particular model. It is called Llama 2 7 billion chat and then Hugging Face comparison conversion. So you see that the guys right here have added the generation config, they have tokenizer, etc. And then they have the model into a safe tensor format. So this is what we're going to use. All right, so you can go through the model card and have a look at the different implementations of the model. Another important piece of information that you need to know is that, at least according to this release, already within the Transformers library, we have support for Llama v2. And this is a very new release, at least on the recording of this video. So you see here that there is an official support for Llama 2 right within the Transformers library from Hugging Face. I have a Google Colab notebook that is already running. And as you can see, I'm using a T4 GPU. For the runtime, I'm using just this GPU, and we don't actually need high RAM option right here. So I've just installed all of the required dependencies along with the latest versions of the Transformers library. I had to log in within the Hugging Face Hub since we're using our token, and this is essentially linked to the permission to download the model. So then I set the model right here, and I started with the tokenizer. Then I'm loading the Llama model using 8-bit, and then I'm passing in that I want this to be a float 16, and I'm giving it to device map auto, which is going to take the model to the GPU. And if we take a look at the NVIDIA SMI right here, we should see how much GPU memory is this using. And yeah, the wallet model takes about 8 gigs of VRAM, so pretty all right to put this model on a single GPU with the 7 billion parameter model. So next I'm going to take the generation config, and I'm going to put the model into evaluation mode. And the first prompt that I'm going to ask the model, and this is pretty stuff, is what are the pros and cons of ChatGPT versus open source large language models. And I'm going to pass this through talk, and I'm going to put the encoding on the GPU, and then I'm going to start the actual inference. So I am doing the inference with no GRUD. I'm calling the model.generate, passing in the encoding right here, and I want 256 maximum number of new the generation config, and this is also the temperature right here. So yeah, you can see that this is essentially taking a lot of time in order to generate something. And after a whole minute at least according to the what I'm right here, or we have a response. I'm not sure why this inference is so slow. It might be something that I'm doing within the config, or maybe this model is still not optimized in a good way. But I'm not going to talk about the inference speed. We're going to have a look at the quality of the outputs, at least for now. So let's see what we have. And first, this is the prompt that we've passed in. And then ChatGPT is a popular language model developed by Meta AI. Well, so the model is making a mistake right off the bat. And open source models available. ChatGPT Pros, high quality results, easy to use, fast response times, continuous improvement. And then again by Meta AI team, which is again wrong. So yeah, this is the first prompt. It doesn't really look that good, but let's continue. The next thing that I'm going to do is to actually remove and I'm going to essentially slice from there to the end. So this will only leave us with the response from the model, which is something that we want. Next, I'm going to try to pass in a system prompt for this model, and we'll see whether or not this is going to make some changes. I'm going to use this function format prompt, and the format prompt is going to be very simple. We're going to pass a system prompt without any additional formatting, and then the prompt itself. So next, I'm going to essentially redo the generation that we did thus far. And I'm going to set a maximum new tokens limit to 128 by default. So yeah, this is pretty much exactly the same thing that we did before. And here is the system prompt that I'm going to use. A salesman and a beet farmer known as Dwight Schrute. So Dwight always replies, or the agent must reply always as such as Dwight. And if you don't know the answer to a question, please don't share false information. So this is the essence of this prompt. And you see that when I run this, I'm going to ask it to write an email to a new client to offer a subscription for a paper supply for 1 year. And let's see what we get here. And again, this response took about a minute. And let's see what the response we get. So we have a subject paper supply subscription offer. Greetings from Dunder Mifflin. I mean from Beet Farm Schrute. Okay. I hope this mail finds you well in your best of spirits and never-ending supply of paper. Okay, Dwight Schrute, Beet Farm Schrute. Don't forget to beat the competition. Wink. Okay. And if you look through this, it looks quite good, at least compared to what I've expected based on the initial prompt. So here I would say that this prompt has worked quite well. And then the write email part is looking quite good, at least with copywriting. It seems that it is getting what I'm telling it to do. Let's try it for, let's say, investment advice. I have $10,000. Yeah, how one should invest it during times of high inflation and high mortgage rates. So this one took a bit more time actually. It took about a minute and a half to complete. So it says that you can basically see that it talks about the inflation and the diversification of investments, etc. So I would say that this type of answer is very good. Again, it is combining something that Dwight would say, and you can see at the end right here, it says that he has to get back to his beet farm, and at the end is ask if you want to invest in some beets. And yeah, I would say that this response is very good. The email one is also pretty good. And let's try it on something else. What is the annual profit of Schrute Farms? And here again, 1 minute. So yeah, so my friend, the next time you're thinking about investing in beet farm, Schrute Farms is the way to go. Trust me, I know what I'm talking about, etc. So, and do I shoot assistant to the regional manager at the MIFON? Okay, so again, very good. It doesn't say what are the profits, but yeah. Let's try this model Llama 2 in programming. A write function in Python that calculates the square of a sum of two numbers. So something pretty basic, I would say. And here you see that I want 512 maximum tokens. And here is the response from that. Again, 1 minute to respond. And this is the function that is providing us with. And it says that if you call this function with the arguments 2 and 3, it should return 9. And I'm actually getting this function, trying it out. And of course, you can probably see the error here. And let's see what we're getting. Of course, it's not going to be 9. Yeah, it looks all right at first, but yeah, when you have a deeper look, you see that the order of the operation is screwing up this one. So yeah, not very good on this first one. And then write a function in Python that splits a list into 3 equal parts and returns a list with the random number of each sublist. Again, about a minute. And here it is actually saying that the function should return a list like this, 2, 5, and then a random element, which is all right. And this is the function that is giving us. I've added this import random at the top in order for this to work. And let's see, you see that we are actually getting a list with the random elements from the first part as the first position, then one of the middle elements as the second position, and then one of the final 2 elements. Yeah, you can see that this behavior is quite consistent within the function. I'm not commenting on the implementation, whether or not it is efficient or not. You have to decide, or correct, you have to decide on your own. But at least from a couple of runs, it looks like that it is working as expected. So it did pretty good on this calling task. And then I've pretty much took the abstract of the paper for Llama 2, and I've asked it to describe the benefits of Llama 2 based on this text. And this is the response. Outperforms open source chat model on most benchmarks, which is good. Maybe a suitable substitute for closed source models. Provides a detailed description of the approach to fine-tuning and safety improvements. Enables the community to build on the work and contribute to the responsible development of large language models. So I would say that this is a very good summary on top of this abstract. So it looks like when you're giving it some text, it can do some pretty good understanding and then summarization, lists, etc. But most of the reasoning tasks, yeah, at least on first glance, it doesn't look to be doing a very good job. So this is a markdown table with the results from the Llama and Llama 2 models on different tasks. This is taken from the paper itself. And this is the question that I'm asking. What is the reading comprehension score for Llama 2 7 billion? And it is a bit hard to see here, but it is, yeah, the 5th from the back. So this is the 1, 2, 3, 4, 5. So the score is 61.3. And you can see that the response is given within 20 seconds. And it says that it is 58.5. And it is also giving us a way to find within this table. Yeah, and this is wrong. So yeah, at least for this one, it didn't do any good. And you see here that the 58.5 is actually for Llama 1. But it appears that it is taking into account the correct column. Either way, the response is not actually correct, or the 8th column from the start. Okay, so another question that I'm asking, calculate how much better percent increase is Llama 2 7 billion versus Llama 1 7 billion on reading comprehension. So I'm expecting it to take the numbers and compare them and calculate a percentage increase. And yeah, this is the response. Use the reading comprehension column for the table. Please let me know if you need any further clarifications. So yeah, this is a pretty fast response, but of course not any good to us. In this video, we took a look at Llama 2, an open large language model by Meta AI that is available also for commercial use. We took a look at the way that this model was trained, the data, the configuration, the context length, and then we took the model for a spin within a Google Colab notebook. We also took a look at the different types of models for the 7 billion, 13 billion, and 70 billion parameter models. So what do you think of this model? Have you tried it out? Please let me know down in the comments below. Please like, share, and subscribe. Also, join the Discord channel that I'm going to link down into the description. And I'll see you in the next one. Bye.